To my awesome 6th graders, this is Miss Jen going over a video with a concept that seems to be troubling some of you guys. I think you completely understand how to divide fractions using keep, change, flip, but I think you guys are getting most confused when we are using mixed numbers. And so I'm going to do several different examples for you today on this video, but I really want you to pay close attention to how we do it with mixed numbers, because it's pulling in a concept from earlier in the year that you're going to have to know how to do. And if you get that wrong, then it completely messes up the whole problem. And if you do not know how to do long division, you're going to get messed up too. So let's get started. We're talking about dividing fractions. I'm going to start off right here with some notes that I'm going to put at the very top of the screen. That way we can use that. So parents, if you're watching, these are notes that I gave your kiddos in class, and it gives you the tips to remember when dividing fractions. Now, I've told the kiddos we only use these tips when we divide. These tricks do not work with multiplying fractions or adding or subtracting. This is specific for dividing fractions. So I've told the kids they have to make sure they look at the sign of operations, and if it's not division, don't look at these notes at all. Use the other notes that I've given them on multiplying fractions, because that is what this is for. If you look at our notes, it says the tips to remember are 3 key words: keep, change, and flip. The reason why we use keep, change, and flip is because dividing fractions can get very complicated and convoluted. And so mathematicians decades ago realized that if I convert using these 3 things, if I convert this division problem into being a brand new multiplication problem, I will get the same answer in a much easier fashion. And so that's why they came up with these tricks of the trade. So let's just say that we have the problem 3/5 divided by 2/4. The trick that we're going to use only with division is keep, change, flip. Those are the key words that you're going to hear the kids say over and over and over again. The first thing you're going to do is keep the first fraction just the same. That is our initial fraction. That's what we're starting off with. We don't manipulate it in any way. The second step is to change the sign, the operation sign, to be multiplication. So where we once started off with division, we are crossing that out and now converting this to a brand new multiplication problem. From there, we're going to flip the second fraction to its reciprocal. Now, parents, you may be saying, what is a reciprocal? In math, the definition of a reciprocal is 2 numbers whose product equal 1. But in layman's terms, in the way that I've explained it to the kids, a trick is if you're given a fraction, to find its reciprocal, you flip-flop the numerator and denominator. So whatever number is on top, which is our numerator, becomes our denominator. Whatever number is on bottom, which is our denominator, now becomes our new numerator. So that's the reciprocal. And that's why when I show my work, and I've asked the kids to do this, I've asked them to show this arrow, proving to me they understand that when you find its reciprocal, you flip-flop the numerator and denominator. Okay, let's look at what we've just done. We have completely converted this division problem to being a brand new multiplication problem. So it's almost as if now this goes away. We have to solve this now. That's why the notes say solve it like a multiplication problem. We have 2 different methods that the kiddos used in class, and you can rewatch the video on that as well if you need to, on how to multiply fractions. But in this particular case, we have to use the first method, because there's no way that I can simplify this 3 and the 5 or 3 and a 2. There's no way that I can simplify the 4 and the 5. But if I wanted to, I could look at this and say, okay, 4 and 2 have a common factor. 2 goes into 2, and 2 goes into 4. And so if I wanted to, I could divide out a 2 in both of those, and that numerator would become a 2, and that denominator would become a 1. From here, there is nothing else that I can simplify whatsoever, so these are the numbers that I'm stuck with. When multiplying fractions, we know we multiply our numerators, so we're going to do 3 times 2 is 6, and then we multiply our denominators, and that becomes a 5 on bottom. This poses another challenge because some of the kids like to leave their answers just like this, but they have also learned that in my class, you must simplify to their simplest terms. You have to reduce it. And so you cannot leave your answer in an improper fraction form. An improper fraction means the top number, the numerator, is bigger than the bottom number. So we have to convert this to be a mixed number. It has to have a whole number and a fraction smashed up against each other. Okay? We have 2 different ways that you can do this. I'm going to use top dog in the house because that's a surefire way you can do it any time. 6 is our top number, so it's our top dog. It goes inside the house. 5 is our bottom number. It's the bottom dog. It goes on the outside. When we do this division problem, 5 goes into 6 one time, and we have 1 left over. Parents and students, this is where you guys are getting mixed up. If you will remember and go back and study in your notes, I have specifically told you not to change a fraction to a decimal here. You're simply doing this division problem to see what your mixed number is going to be. This is changing a fraction to just a mixed number. And the number that you get on top, your answer there, that first quotient, is your new whole number. So that's going to be our whole number. The leftovers that you have, some people call them remainders. The leftovers become your new numerator. And whatever was your bottom dog is a constant. It does not change. So it just comes over. So our final answer of 3/5 divided by 2/4 is 1/5. That's the basic dividing fractions. If you do a division problem with a whole number, you're going to work this the exact same way to where if I had, let me get a new card. If I have 3/5 divided by 2, the kids know the way to convert a whole number into a fraction is to put a peg leg underneath it or just to put a 1 underneath it. That's what they have to do. From here, we have to do the conversion from a division problem to a multiplication problem using keep, change, flip. So I keep the first fraction. I change the sign to multiplication, and I flip the second one to its reciprocal. Then I multiply my tops and multiply my bottoms, and there's my final answer because 3/10 can no longer be reduced. Okay, one final problem, and this is what I think a lot of the kids are having trouble with, and I'm going to flip these notes over, is how we divide using mixed numbers. In order to do this skill, the kids are having to reach back from the first part of the year where they learned how to convert a mixed number to an improper fraction. So let me quickly show you how to do that. It's written right here, but I'm going to work it through for you. If I have the number 1 2/3, that is a mixed number. The way that I convert that to be an improper fraction, and these are always going to be an improper fraction, the top number is always going to be bigger because you're dealing with a number that's bigger than 1. What we do is we multiply the denominator times the whole number, and we get a little product, and I always write the number right there. From there, we add our numerator together, and our top numerator is 5, and our constant stays the same, and that becomes 3. So our improper fraction that we've created from that mixed number is 5/3. But for right now, I want us to look at a mixed number problem. And I want you guys and parents to know these are more complicated. they are not as easy as some of the other ones that the kids are going to see. So, because they have to reach back and remember things from the earlier in the year, and they have been told that we are going to be building on these concepts all year long. And so that's the reason why I've given them their journal. They've got to go back and study those notes. The problem that I'm going to do for you now is 4 1/5. That's a mixed number. I want to divide that by 4 2/3. 2 mixed numbers. Now let's look at these notes up here. The steps to remember is we first have to convert both of the mixed number, or if I'm only given one mixed number to be an improper fraction, just like we did over here. We have to do that first. So that's why the first step is write both mixed numbers as fractions. Let's do that right now. 5 times 4 is 20. 20 plus 1 is 21, and our constant stays the same. Divided by, we have not converted it yet. It is still a division problem. Is 3 times 4 is 12, plus 2 is 14 over 3. Here is our division problem. We have done the first step. Okay, so now we have the division problem, 21 over 5 divided by 14 over 3. We've done the first step. The second step that it says right here is to use KCF from above. Well, we remember that KCF means keep, change, flip. That's where we're going to find the reciprocal of the second fraction. So we're going to use KCF. Keep the first fraction exactly how it is because that's what we're starting off with. Change the sign from from division to multiplication, and then flip the second fraction to its reciprocal. So instead of being 14 over 3, we're flip-flopping, and it will become 3 over 14. Now, if we look at this new multiplication problem, it's like this has gone away. We now need to see, first of all, can I simplify ahead of time to make my math and multiplication and my reducing easier? And if we look at 14 and 21, both of them have a factor of 7. So if I divide a 7 out of both of those, this top one becomes a 3, and this bottom one becomes a 2. So as I look at my numbers now, I have a 3, a 3, a 5, and a 2. Those are all prime numbers. I can't simplify that anymore. So now I'm to the point where I multiply my numerators. 3 times 3 is 9. I multiply my denominators. 5 times 2 is 10. And my final answer is 9 over 10. I think the biggest problem for kiddos is when they get a big fraction at the end where they have to figure out what the mixed number is. So the very last problem that I'm going to do is one like that, and hopefully we can make some better sense of it. Let's see if we can do 4 3/5 divided by 4 1/4. Okay, they're both mixed numbers. So the first thing we have to do is to write both mixed numbers as fractions. This is the process that we're going to go through right here. We have to convert both mixed numbers to improper fractions. We multiply 5 times 4, which is 20, and we add 3. That becomes 23 over 5. We have not converted this to a multiplication problem yet, so just put your division sign there. To convert this last mixed number to an improper fraction, we're going to multiply 4 times 4, which gives us 16, and add 1, which gives us an improper fraction of 17 over 4. Now here is our new division problem. Now we're going to use keep, change, flip to solve it as a multiplication problem. So here we go. 23 over 5, we're keeping it the same. We're changing the division sign to be multiplication. And we're flipping the second fraction to its reciprocal, which means that will become 4 over 17. Now, this is a brand new problem. It's like the division problem did not exist. What we're going to do now is look at this. It does not appear that any of these numbers